In the guided notes, I have students go over a scatter plot with me. We plot the points, we scale the graph, talk about the importance of how to scale and label the graph so that somebody reading it would know what two variables they're comparing. So this scatter plot's comparing temperatures in degrees Celsius outside compared to total sale of ice cream for a business. And so you have high positive correlation. We talked about the points are really close together, about to form almost perfectly linear. And then I have a positive correlation because it's going in a positive direction. So once we scale and label the graph, plot the points, we draw that line of best fit. We try to keep the same amount of points above and below the line. And then we choose 2 good points. I really emphasize that these 2 points can be data points or they cannot be data points as long as they're on the line of best fit and you can name the x and y coordinate. Since most of the data points were decimals in this case, I selected 2 points that were not data points on the line of best fit. And so then we try to write the equation for that line of best fit. So how do you find the slope of that line? We're going to subtract the difference of the y values, 700 minus 200, over the difference of the x values, 30 minus 10. That's going to be 500 divided by 20, and that would be 25. So now that we have the slope of that line, we need to go ahead and plug into y equals mx plus b. We're going to choose one good point, x and y, and plug in x, y, and m and get solve for b. So that's going to be 200 equals, the slope is 25, times x, which is 10, and you're solving for b. So when we go through and solve that, we get 200 equals 250 plus b, and when you subtract 250 from both sides, you're going to get b is equal to negative 50. And so it looks like my line's going through about 0, but I'm going to go ahead and go with that the y-intercept would be negative 50 with the prediction equation that I made with the 2 good points. So now that we have the equation, it's going to be y equals, let's go ahead and erase that. So now if we write that equation, our prediction equation is going to be y equals 25x minus 50. And then we're going to use that to predict data points that we don't see in the data. In between the data points, we're going to interpolate what one of the data points would be if the temperature outside was 17 degrees, and we're going to extrapolate what we outside of the data points with 30 degrees Celsius. It looks like at 17 the graph's showing that the values should come between, the cells should be between 300 and 400, but let's go ahead and use the prediction equation and figure that out. So 25 times 17 minus 50 to predict total cells when it's 17 degrees outside. 17 times 25 is going to be 405. So y would equal 405 minus 50. And so the total cells outside would be 355. And we said it would be between 3 and 400 is what our line is showing. And then if we try to predict outside of the data points at 30 degrees Celsius, the graph showing at 30 degrees Celsius should be right at 700 because that's one of the data points we selected. And so let's go ahead and use the prediction equation to see what we come up with. So y would equal 25 times 30 minus 50, and 25 times 30 that's going to equal 750 minus 50, and we do get 700. But we knew we were going to get that because we already had that point exactly on the graph. So, but the prediction equation, that's the whole point. We probably should have predicted a point further out than 30. But the prediction equation is the whole point of the scatter plot, to come up with that formula or that equation that you can predict data points that you can't see on the graph.